Hello, my name is Stephen Cowden, Applications Manager at Microchip Technology. Today I have the absolute pleasure of introducing Microchip's new code generation tool, the MPLAB Code Configurator. This tool is a very easy-to-use NetBeans plugin for MPLAB-X. It generates both driver and initialization functions for peripherals that the customer can use in any application. For the video, we'll be using a PIC-M2 Plus demo board with a PIC16F1937 installed, along with the MPLAB Realize in-circuit emulator. For the IDE tools, we'll be using the MPLAB-X version 1.90 and the XE8 compiler 1.21. Let's first open MPLAB-X and start a new project. First, go to File and select New Project. We'll use Embedded and Standalone, so click Next. Enter in PIC16F1937 as a device and click Next. There's no header on this, so select Next. Select Realize and then select Next. No plugin board is being used, so select Next. We'll use the XE8 compiler version 1.21, click Next. I'll name the project MCC Demo. Click on the box to set this as a main project and then click the Finish button. For this video, we already have the Code Configurator plugin installed. For more detailed information on installing the Code Configurator plugin, please see our previous video titled Installing a NetBeans plugin. Click on the MPLAB-X Code Configurator under Tools Embedded to start the application. When it first starts, you will see two main sections. The center section is the Composer area. This is where you will configure the settings for each peripheral. It also has the Generate Code, Resources, and Pin Manager buttons. We'll go over this area in greater detail in a second. The other area on the left is the Resource area, which has two main sections: the Device Resource area and the Project Resource area. The Device Resource area contains all the peripherals supported by the Code Configurator. The Project Resource area contains all the selected peripherals that will be used in the next upcoming code generation. To add a peripheral to the Project Resource area, simply click on it from the Device Resource area. In between the Project Resource area and the Device Resource area is a search window. You can use this window to only list the peripherals needed for a specific application. For example, say the user wants to see what peripherals would be used for motor control. Simply enter motor control in the window, and now only the peripherals associated with motor control will be listed in the Device Resource area. Please feel free to experiment with this, but for now, let's delete motor control and continue on. Expand and select GPIO from the Device Resource window, and this will bring it up into the Project Resource area. This will also do two other things: launch the user interface into the Composer area and start the Pin Manager. Let's cover the Pin Manager first. The Pin Manager has two main windows. The upper is the package view, and the lower is the table view. The package in the package view can be changed via the package button. For our project, we're using a 40-pin DIP package, so we can leave it alone for now. You can zoom in and out of the package view by holding the control button and scrolling the mouse wheel. The table view lists all the IOs selected for the peripheral and the pin locations. A blue lock indicates that the pin is available on that peripheral. However, since we are using GPIO, all IO pins are available. The reverse pin order button changes the port order for the IOs between 0 to 7 and 7 to 0. You can select between horizontal and vertical view for the table view, but we'll leave it in the horizontal view for now. Let's select a couple IOs from the table view. The PIC-M2 board has 4 LEDs on port pins RB0 to RB3, so let's use them. Clicking on the little blue lock on RB0 to RB3, you'll see a couple things will happen. In the table view, the lock will lock and it will turn green. In the package view, the IO will turn green and the IO name will now be displayed on the package. In the Composer area, the selected IOs will now be displayed in the GPIO user interface. In the Composer area, the GPIO user interface has several columns used for configuring the selected IO pins. Let's set all the IO pins to output by clicking each box in the output column. Note that deselecting or not selecting the box would result in the I/O pin to be an input. Let's leave the initial starting values of pull-ups and IOCs in the default states. You can edit the pin name to reflect what is connected to the I/O in the custom name column. This can be done one at a time or in parallel. Let's highlight all the pins and type in LED 0 and press Enter. The tool will enumerate the remaining I/Os automatically. Notice that the names of the I/O pins also changed in the package view window of the Pin Manager. Selecting Systems from the Project Resources area displays the settings for the oscillators and configuration bits. For now, we can leave them at the Code Configurator default settings. OK, let's click on the Generate Code button. After it's complete, if you expand the header file and source file folders under the project window, you can see the files that the Code Configurator generated. The Code Configurator detected that there was not a main.c in the project, so it generated one. However, if one was present, the Code Configurator would not have generated one or overwritten into it. However, the user would have to add in 2 lines of code into their project to utilize the initializer and driver functions that were generated by the Code Configurator. Let's open main.c and scroll down to the first pound include. The first pound include and the system underbar initializer function are the 2 lines of code the user will need to add to their project if a main.c file already existed. Let's place the cursor under the system initializer function and type in the letters LED and use the MPLABX autofill feature by pressing Control Spacebar. This is a cool feature of MPLABX that the Code Configurator uses very well. By doing this, you will see a list of all functions and variables and macros that start with the letters LED. All the macros in the window were generated by the Code Configurator and are available for use. Let's select the LED 0 underbar set high macro and place the parentheses and semicolon at the end of the line and make and program the device. When it's complete, you should see the LED 0 on RB0 light up. And there you have it. Well, that ends our time for today. But please feel free to experiment further with the tool. And for more information, please visit microchip.com/MPLABX. Thank you for watching.